Hello everyone. In this video we are going to see a very famous question like what this keyword or this term means static in this STA. What is the significance of this and why it is static, not dynamic? Okay, before going to that, I will just like to share a small example and I will ask a simple question. What do you see the difference in these three things? So you must be say the length is first one you said that the length is different. Okay, I accept that. You said that its breadth is different. Okay, three photo frames are there, so breadth is its height is also different. Okay, that is also accepted. Any more parameters? Okay, one parameter would be time. Like let's say this is of 2006, this is 2009, and then this is 2025. So time is a very important parameter, and in VLSI also we should always careful about the synchronous circuit, because their synchronous circuit, its criteria should meet, like whether the data is my sampling at a required clock edge or not. So that defines, and if there is a violations, then that circuit will not be in a synchronous way. Okay, so it will latch some incorrect data. So that's why STA is very important. Now coming to the term, why we address this as a static and what does it means? Because what we are saying is, if I just take me one minute. So this so if I say that STA method do not require applying stimuli observing their dynamic outputs. Okay, so suppose if I am having a circuit and I am applying some stimulus like 0 0 0 and my output must come 1 1 1. So this is like a dynamic inputs, like I am saying that 1 0 1, then what will be my output. So these are the dynamic things, like we are applying stimuli of different kind of set of inputs, and for that we are analyzing our outputs. So that thing is a dynamic thing. Okay, in STA we are not performing the functional verification because that part has already been done. When we move from RTL to GDS, then that part has already been achieved. So when the STA comes, it must be done in such a way that my functional verification has already been done. So we don't need to apply the stimuli and check what is happening. No. Okay, what we do in STA is we just see whether they are meeting the worst case scenario or not. Suppose I'm having two types of flip-flop, and this is my launch clock, this is my capture clock, and this is my combinational delay. So if they both got clock, so I will see like if my clock is going into launch and capture launches some data to launch, capture some data to capture, whether that is sampling at a right clock edge or not. So we talk about worst case scenario, like data go how much time it will get, how much for time it should be here. So again, that is a setup time you might be knowing, and that is the whole time you might be knowing. So we our general analysis only happens like whether these data are getting collected at a right positive edge and it is stable for some time or not, and that time is basically worst case scenario. We don't talk about best case scenario because that is not what STA meant. Okay, so STA, if I just to conclude my point, the STA is a static verification technique. Okay, it's not dynamic, like we are applying multiple inputs and we are checking what output will be there, whether it is meeting its functionality or not. It's not like that. It's simply that static verification technique. Okay, and this is stimuli independent. Like it shouldn't be like 110 or 110. What is my output? Okay, and it is a stimuli independent technique to verify worst case behavior of a circuit. Worst case behavior is that my data should be here within a 4 nanosecond. So before 4 nanosecond, my data should be there, and that is my worst case. We cannot violate this. Okay, and how much time my data should be here. So that should be my consideration. Thank you.